I'm Anil Kumar, and here is an application question, question number 7, page 170 from Nelson Calculus and Vectors. I hope it will help a lot of my viewers on the YouTube and some students who are having a lot of difficulty in solving this particular question. So the question here is, find the constants a, b, and c such that the graph of function x cubed plus ax squared plus bx plus c will increase to the point minus 3, 18, decrease to the point 1, minus 14, and then continue increasing, right? So what we are given here is a condition that the function f of x increase to the point. So the function is kind of increasing to a point which is minus 318, then it decreases to a local minimum value, and then it further increases. So what we are indirectly given are local maximum and minimum points. So this point, which is a local maximum, is at minus 318, and the minimum is at 1, minus 14. Now we are also given with that these points are on the graph of the function, correct? And at local maximum or minimum, the derivative will be 0, horizontal line. So at this point, f dash x is going to be 0, right? So here also f dash x is equals to 0. Now with that information, you get actually 4 equations. You have 3 variables to solve for, so that should not be difficult, right? So let's begin by saying that f of x is equals to x cubed plus ax squared plus bx plus c. So what is the derivative of this function? Derivative is 3x squared plus 2ax plus b, right? So we know derivative of these 2 points should be 0. That gives us 2 equations. So we'll write derivative at 1 is, substitute 1 here, so we get 3 plus 2a plus b, and this is 0. So we say 0 equals to 3 plus 2a plus b, right? Now the second derivative, which is 0, is at f dash at minus 3, right? So if I substitute minus 3 here in my derivative, minus 3 square is 9, 9 times 3 is 27. So I'm just combining all these calculations. Minus 3 times 2 is minus 6. So we get minus 6a plus b. And that should also be 0. So we have 0 equals to 27 minus 6a plus b, right? So that gives us 2 equations with 2 variables, and we can always solve for those 2 variables using these equations. So let me call this equation as equation 1 and this as equation 2. So now we'll solve these equations to find the value of a and b, right? So if I do, let us say equation 1 minus equation 2, then what do I get? In that case, 1 minus 2, so I get 0 on the left side, so 0 equals to this. When you take away 27, you get minus 24, and 2a minus 6 will give you plus 8a, and b minus b is 0, right? So from here, you say minus 24 plus 8a is 0, that means a is equals to 3, right? So 24 divided by 8, so a is 3 for you. So that is how you find the value of a. Now once you have the value of a, let me say this is my equation number 3, I can substitute a in equation 1 and find the value of b. So we have 0 equals to 3 plus 2 times 3, which is the value of a, plus b, right? So that gives me the value of b as 0 equals to 3 plus 2 times 3 is 6, right? So plus b, or b equals to minus 9. So we get value of b as minus 9. Let me call this as equation 4. Okay, so we know a and b now. Now what we'll do is we'll use one of the points to find the value of c. So f1 is minus 14. So f1 equals to minus 14. And if I substitute 1 in my equation, I get x cubed plus a plus b plus c. Now we know that x is 1, so I'll write 1 here. For x cubed is 1, plus a is 3 for us, plus b, which is minus 9, plus c. So from here we can calculate the value of c, right? So let's bring all these terms together. We have minus 14, 9 and this is 4, so that gives me minus 5 plus c, or c is equals to minus 14 plus 5, which is also minus 9. So c is minus 9 for us. So now we get our answer, and that is that a is equals to 3, b is equals to minus 9, and c equals to minus 9, correct? So these are the values which will satisfy the given condition. I hope you understand and appreciate the steps. Since there are 3 variables, we need 3 equations. We got 2 equations from the derivatives. The third one we got from the value of the function itself. Then solve simultaneous equations and get your answer. That is how you could solve such questions. Thank you and all the best.